Welcome to 1.5 Units of Measurement. So in this video, we're going to talk about how we measure things in chemistry. Chemistry is the study of atoms and molecules, and so in this case, we want to think about how do we measure that. So a lot of properties are what we're going to call qualitative, and so they have a unit associated with the value that we've defined. So when you think about that in your real life, if by chance we determine that there are 12 potatoes set out for dinner, those could be small, large, red, yellow, lots of different types of things fall into the category of potato. But if you want to say we need to add 58 grams of potatoes, that's a unit that is the same everywhere. So the units are associated with the values we've defined. And so what we're going to learn about today are what does that exactly mean? So where did the units come from in chemistry? So in 1960, at the international meeting of the Système International des Units, this conference, which was entitled the Général des Poids et Mesures, otherwise known in English as the General Conference on Weights and Measures, scientists agreed on 7 base units that all scientists would use. So we now have these 7 base units. And so the thing is, why is this important? This allowed scientists in the United States to compare data collected in France or in other countries in Europe or in Asia or really anywhere in the world. So all of the data is the same. Sometimes when we look back at the literature, what we see is people talk about different units, and so this conference allowed this to happen. Most recently, this conference met, I believe, 2 years ago, and they redefined the kilogram. So they added some more decimal units and set up a few other things. So what are the units that we are most likely to encounter here in Gen Chem 1? So we're going to talk about length right here, which is how long something is. And so we tend to think about that in meters. So in America, we talk about inches. A lot of the world uses meters, kilometers, instead of inches, feet, and miles. Typically, when we talk about mass, we'll use kilograms, which are 1,000 grams. A lot of times in Gen Chem, we just live with the grams. So temperature is often in Kelvin. And so we can use either of these equations in order to do that. Now, both of these equations will be provided on an equation sheet. So you don't need to memorize these. However, it would be beneficial for you to learn how to use those. Most of the time, we will be using this equation to think about how to convert Kelvin into Celsius or Celsius into Kelvin. And in this case, we know that the degrees Celsius plus 273 gives us the Kelvin. So numerical prefixes. Now, what is this? What are we talking about here? When I say that I ran 5K, we all know, or we can kind of come up with the fact that that's a 5-kilometer race. So that means we ran 5,000 meters. So in addition to the SI units or the prefixes or the units of different measures, these conferences, the General Conference on the Weights and Measures, agreed to prefixes for the units. Now, when we think about different things, we know basically if I tell you I have 100 grams or 1,000 grams, you can see that those start to make sense. If I use scientific notation, we can think about that a little bit better. But these units are going to say that 1 million grams is 1 times 10 to the 6 grams. So this here is scientific notation. And so the scientific notation is basically 1 times the number of placeholders to that power, grams, which is also something called 1 mg G. Now this big M here equals mega. And mega is a unit that basically says it's 1 times 10 to the 6th of anything. So you could have megagrams, megaminutes, megameters. This is different than mega man, but that's what we're thinking about here. So on this next slide, we have this statement. So we in this class are mostly going to, you need to memorize these. Now, memorization in this class is a little different this year because we're going to do a lot more asynchronous material. So what I want you to think about is you want to know how to use them. A lot of them will be pretty commonly used. So you can kind of look at centi, kilo, milli, micro, and nano. Those are the ones that we tend to think about the most. Although when you think about your internet speed, we talk about gigahertz, which tells you that it's 1 times 10 to the 9th hertz, or a lot of hertz. So you want to memorize these. And so what your goal is to be able to convert different units to something else. So if we think about, if you have 100 centimeters, how many meters is that? So we know that there are 100 centimeters in 1 meter, and that's going to give you 1 meter. Not the best example I've ever come up with, but we can start to make unit conversions in this way. So some other units that we're going to come in contact with are what are called derived units. A derived unit is basically when we take other units, put them all together, multiply them, divide, get them to interact, and we couple them with something else. Volume is a 3D space. Density, also something that is derived. So first we're going to talk about volume. This is the total space that a substance occupied. So we can think of volume, typically when I think about volume, I think about liquid volume. How many liters are in this container? What is the square footage or the cubic space inside of a building? But it can be a solid. So you can think about the volume of something. If you were to buy a pack of Oreos, some of that can give you information. It will often report the value. So for a solid, volume is calculated length times width times height. So this is for a solid. So if you look at this graphic right here, we can see that it is 1 centimeter by 1 centimeter by 1 centimeter. And so the volume would be 1 centimeter cubed. So when we think about liquids, a lot of us right now carry hydro flasks or a Yeti or a tumbler or something else. And so a lot of those tell you either how many ounces are in there or how many liters or milliliters it can contain. So when we think about volume of liquids, 1 milliliter, so for liquids, 1 milliliter is equal to 1 cubic centimeter. Now, the thing is, this is probably common knowledge to you already. So if you watch a lot of medical dramas, a lot of times they'll say, I need 5 cc's of something. Cc's are cubic centimeters, otherwise known as milliliters. So this is one of the defined things that we just need to know. We need to know that 1 milliliter is equal to 1 cubic centimeter. This is going to be really important when we think about density. So let's calculate the volume of a fish tank. So we've got a nice little fish tank here. And so I want to know what is the volume of a fish tank with a height of 11.3 centimeters, a width of 8.2 centimeters, and a length of 1.49. So we know that volume is equal to length or height times width times length. Now we notice that our units are centimeters, centimeters, and meters. So the first thing that we're going to do is convert either all into centimeters or all into meters. In this case, the problem doesn't specify. So you can choose what you would want. on an exam or in ALEKS, the homework system, it will specify. So I'm going to convert 0.149 meters into centimeters. So on 1 meter, there is 100 centimeters, and that's going to give you 149 centimeters. So now we're going to multiply all of these numbers together. We have 11.3 centimeters times 8.2 centimeters times 149 centimeters. When you plug this into your calculator, what you should get is 13,806.34 cubic centimeters. Now, this video hasn't talked about significant figures, but significant figures are really important. So when we look at the problem, we can see that this value has 3, this value has 2, and this value also has 3. So that tells us that our final answer needs to only have 2 significant figures. So when we look at this, we can see that that's going to make it 13 something thousand maybe, but rounding 5 and up, round up. So this is going to end up being 14,000 cubic centimeters, or 1.4 times 10 to the 4 cubic centimeters. I will always take both in this case. And so ALEKS will often, the homework system we're using this semester, will ask you to create it into scientific notation. So what we're going to talk about next is density. Density is what allows ice to float. If you're a big fan of oil and vinegar salad dressings, you'll notice that you kind of have to shake those up, or a lot of Italian dressings have 2 layers. So it tells us that density allows different things to be different layers or different weights. So the mass per unit volume, grams per mil or grams per cubic centimeter, don't forget that 1 milliliter equals 1 cubic centimeter. So density is the mass per volume, right? So what can we think about in our life that we tend to see in this case? So sometimes if we pick up a box, if you're moving and you have a box of pillows or a box of books, same size box is going to weigh differently. So the density of those boxes will be different. And so it's going to tell us how tightly packed. This is a physical property. So we can use it to identify a sample. So the more dense layer is on the bottom. So the lighter layer is on top. So now we have some examples. So the first example is, what is the density of mercury if 1.00 times 10 to the second grams occupies 7.36 cubic centimeters? So we know that density is mass divided by volume. And so they've provided for us both the mass and the volume. So we're going to take our 1.00 times 10 to the second grams divided by 7.36 cubic centimeters. When we plug this into our calculator, we should get 13.6 grams per cubic centimeter, or 13.6 grams per mil. So now for the second one, we'll set this one up down here. The question asks, calculate the volume of 65 grams of methanol if the density is 0.791. So density can really be a tool for us here in chemistry. So if density is 0.791 grams per mil, that tells us that there are 0.719, nope, it doesn't tell us that, 0.791 grams in 1 milliliter. So we're going to use this similarly to allow us to convert different things. So we're going to take our density. We're going to take our 65.0 grams of methanol, and we're going to multiply by the inverse or divide by the density, 0.791 grams in 1 milliliter. And so that's going to give us 82.2 milliliters. I'll make that look a little bit more like an 82.2. So here are two examples of how we can calculate density.